In this video, we will talk about how to find the first n terms of a binomial expansion with a fractional exponent. So here's the formula we can use. If we have some binomial 1 plus x raised to the power of n, where n is a fraction, then to expand it, we can use the formula 1 plus n times x plus n times n minus 1 over 2 factorial times x squared plus n times n minus 1 times n minus 2 over 3 factorial times x cubed plus, and we just follow this pattern on and on and on indefinitely. Now it's worth noting that this series is only valid for x values between -1 and +1. So when we do expand a binomial like this with a fractional exponent, we need to specify for what x values is the series actually valid for. So let's check out an example of how to use this formula. This says find the first 4 terms of 1 plus 3x to the power of 1/3. So we have a binomial raised to a fractional exponent. So to expand it, we can use this formula up here. So when we expand it, it would be equal to the first term is a 1, so we'll say 1, plus the second term is n, where n is the fractional exponent, so that's 1/3 in this case. So we'll say 1/3 times x. So x is the second term in the binomial. So in this case, x is equal to 3x. So we'll say multiplied by 3x. That's our second term. And then we add our third term. So n, again, that's the fraction. So we'll have 1/3 times n minus 1. So 1/3 minus 1. And that's all over 2 factorial. So 2 factorial is just 2 times 1, which is 2. So we'll just write a 2 right here. And that's multiplied by x squared. So again, x is the second term in our binomial. So in this case, we have a 3x. So we'll say times 3x squared. So that's our third term. Our fourth term will be, we have n, so the fractional exponent of 1/3. So let's write 1/3 times n minus 1, so 1/3 minus 1, times n minus 2, so 1/3 minus 2, and that's all over 3 factorial. So 3 factorial is just 3 times 2 times 1. So 3 times 2 is 6 times 1 is still 6. So we can write a 6 right here. Times x cubed. Remember x, that's the second term in the binomial. That will be 3x. So we'll say times 3x cubed. Let's go ahead and start simplifying. So we get 1 plus 1/3 times 3x. Well, when we multiply these, the 3's cancel out and we're just left with x. So we just have an x. Now over here we have 1/3 times 1/3 minus 1. Now when we have 1/3 minus 1, it might help to think of it as 1/3 minus, we could rewrite the 1 as 3 over 3, since that's the same as 1. So when we do 1/3 minus 3/3, that's -2/3. So what we have here is 1/3 times -2/3. So if we do that 1/3 times -2/3, we multiply the numerators, we get 1 times -2 is -2, over 3 times 3 is 9. So here we have this whole numerator right here is -2/9, and we're dividing that by 2. Now, when we divide by 2, that's the same as multiplying by the reciprocal of 2, which is 1 over 2. So what we get is -2/9 times 1 over 2. Now, when we multiply these, we can see that we can cross-cancel these 2's, and we're just left with -1/9. So this whole expression is -1/9. So let's write that, -1/9, and we still have times 3x squared. Now when we have a term like this squared, we have to square the 3 and square the x. So 3 squared is 9, and x squared is just x squared. So we'll have times 9x squared. All right, let's move on to this last term over here. I'm going to go ahead and clear out some of this space. Okay, so we have 1/3 times 1/3 minus 1. From the previous term, we found that 1/3 minus 1 is -2/3. So let's write that right here. And then we have times 1/3 minus 2. Now, if we want to think of 1/3 minus 2 as, we could write 2 as 6 over 3, since that's the same as 2. So 1 minus 6 is a -5, so we get -5/3. So here's what we have in the numerator. We have 1/3 times -2/3 times -5/3. So let's see what we get. 1 times -2 is -2, times a -5 is a +10. In the denominators, we have 3 times 3 times 3, which is 27. So this entire numerator is 10 over 27, and we're dividing it by 6. which is the same as multiplying it by 1 over 6. So when we multiply these, we can cross reduce and divide the 10 by 2, make it a 5, divide the 6 by 2, and make it a 3. So we get 5 times 1, which is 5, and 27 times 3, that turns out to be 81. So this whole portion right here, this is 5 over 81. So let's write that. Plus 5 over 81. And then lastly, we have that multiplied by 3x to the power of 3. So again, when we're raising it to the power of 3, we need to take 3 to the power of 3, which is 27, and x to the power of 3, which is just x cubed. So we get times 27x cubed. Okay, so we're almost done. Let's simplify a little more. So we have 1 plus x, negative 1/9 times 9. When we multiply these two, the 9s will cancel out, and we'll just be left with a negative 1, or just negative x squared. And in this last term, we have, when we multiply 5 over 81 times 27, the 27 we could divide by 27 to make it a 1, and 81 divided by 27 is 3. So this simplifies to 5/3. So we just have 5/3 times x cubed. So this is our final answer. These are the first 4 terms of the binomial expansion of this original binomial. The very last step is we just need to specify for what x values is this valid. So we said when we have this formula, it's valid for x values between -1 and +1. But notice that in this example, our x, so our second term in the binomial, we used a 3x. So what that says is that it's valid for -1 is less than 3x is less than 1. So to get x all by itself, we just need to divide all the terms by 3. So we'll notice that these 3's cancel out and we're left with -1/3 is less than x is less than 1/3. So this series is only valid for x values between -1/3 and +1/3. So that will be our final answer for this one.